Hi, hello, welcome to Technical YouTube channel. This is your Nikhilesh Sriram. We have already completed 3 episodes regarding basics of digital electronics. This is our final episode based on the topic basics of digital electronics. I have mentioned the previous 3 episodes link in description. For watching that videos, go to description and search there. Let us, without any delay, let's move to today's episode. The topics that I am going to cover in this video are specifications of digital ICs, TTL circuits, TTL NAND gate, CMOS NAND gate, and ECM circuit. First topic, specification of digital ICs or characteristics of digital ICs. There are total 9 characteristics of digital ICs. They are propagation delay, power dissipation, speed power product, fanning, fan out, input logic level, output logic level, noise margin, and operating temperature. First one, propagation delay. What is a propagation delay? Propagation delay is the maximum time taken by an output to change its state in response to input. This is called propagation delay. Propagation delay determines the speed of the logic gate, and it is denoted by small t sub p, and it is measured in seconds. Power dissipation. What is the power dissipation? We all know dissipation means loss. The power loss in an IC is known as power dissipation. This parameter is very important while considering a IC. If the power dissipation of an IC is very larger, then it reduces the lifetime of the IC and reduces the working capacity of the IC. So while buying an IC, this parameter is very important. Remember, power. Third one, speed of power product. It is defined as the product of propagation delay and power dissipation. It is measured in picojoules and it is also called as figure of merit. The formula for figure of merit means figure of merit is equal to propagation delay into power dissipation. That is equal to Tp into Pd in picojoules. Fourth one, fanning. Fanning of a logic circuit that gives the number of inputs can be connected to the logic circuit and operate without any impairing the primary parameters. Fifth one, fan out. The fan out of a logic circuit gives the number of outputs can be taken from the logic circuit and can operate properly. Let us see the circuit diagram for fan in and fan out. Let us consider this is as a logic circuit. All the number of inputs connecting to the logic gate is fanning. Comes under fanning. And the outputs connected to the logic circuit, this is comes in the fan out. This is about fan in and fan out. Sixth one, input logic level. In case of any logic gate, the output of a logic gate depends upon the input given to it. The input is said to be logic 0 when the voltage is given low voltage. In such cases, there are two divided into two logic inputs, that is low logic level and second one as high logic level. Low logic level and high logic level. First of all, let us discuss about low logic level. If the input is 0, if the input logic is 0, then it is called as low logic level, and if the input is given as 1, input logic is given as 1, that is called as high logic level. These two logic inputs are called as worst case voltages. Seventh one, output logic level. The output voltage of logic 0 is 0 volts, and the output logic 1 is 5 volts. Due to some voltage variations and voltage drops at the resistors, these values may be vary. So inside the values from 0 volts to 0.4 volts is considered as logic 0, and from 2.4 volts to 5 volts is considered as logic 1. Let us see in this diagram. You can see clearly this is the actual logic low value and this is the logic high value. Due to some voltage drops, the values may be changed. This from only for 0.4 volts, and the high voltage is occurs from 2.4 volts. So these values are considered as logic 0. And noise margin. What is a noise? First of all, what is a noise? The unwanted electrical signals are called as noise. It can appear while connecting the logical circuits. The ability to tolerate the noise is known as noise immunity. The amount of noise immunity, the amount of ability to tolerate the noise is called as noise margin. Ninth one, operating temperature. It is the temperature where the IC can perform properly. The range of temperature that IC can perform properly. There are two ranges of ICs can perform. First type of ICs can perform at 0 degrees Celsius to 75 degrees Celsius. This is used for consumer and industrial applications. And the second type of ICs that can perform from 55 degrees Celsius to minus 55 degrees Celsius to plus 125 degrees Celsius. This is used for military applications. These are all the characteristics of digital ICs. Next topic is TTL NAND gate. In TTL NAND gate, we use three transistors. T1, the double emitter transistor, and T2, T3 as normal transistors. When we give the both logics A and B as 0, then the T1 will be in on state. When the T1 is on, then the logics flow directly from base to the output, then the output we get is high. When we give 0, 1 and 1, 0, the same case repeats, then the output is high. When we comes to logic 1 and 1, then T1 will be in off state, then the logic flows to T2 base, and T2 becomes on state, and it gives the logic to T3, and T3 will be in on state through emitter of T3. Then the output goes to the ground. Then the output collected at Y is 0. Then we get the output as low. Let us see the truth table for TTL NAND gate. What is the TTL NAND gate means? The NAND gate we are writing as with transistors mode. The output we want to get is the what are the outputs we are getting in NAND gate. We want to get that outputs. What are the outputs of NAND gate means when both the inputs are high, then only the output will be low. In other cases, the output will be high. Let us see the truth table. When the two outputs are low, the T1 will on, the output we get is high. When the any one of the input is high, then same repeats, the output will be high. When both the inputs is high, then only the output is low. Next topic is totem pole output TTL NAND gate. We have TTL NAND gate. Why we are going to totem pole NAND gate means totem pole output means in case of TTL NAND gate there will be a propagation delay time. To reduce the propagation delay time, we are using a totem pole output to for arrangement for the TTL NAND gate. It is arranged. The transistor T4 is arranged at the output end. Let us see the working of your totem pole TTL NAND gate in circuit diagram. We already discussed there is a specially designed T2 double element transistor T1 is arranged at the input side, and that there we are using in this type of TTL NAND gate the three transistor T1, T2 and T3. When we give both the logics are low or any one of the logic is low, then the transistor T1 will be in on state. Because the transistor T1 is in on state, the output will be flows through the output of the transistor T1 goes from the base of the transistor T1 to transistor T4, that is totem pole transistor, to the resistors RB and RC2. When the logic is when transistor T4 gets the logic, then the transistor T4 will be on. When the transistor T4 will be in on state, the transistor T4 releases the output from the emitter of the transistor T4 to the diode, and the output will be corrected at the output N Y will be in high. This is in case of any one of the output is high, any one of the input is high, or both the inputs are low. What will be in the case of both the inputs are high? When both the inputs are high, the transistor T1 will be in off state. When the transistor T1 will be in off state, then the transistor T1 gives out the logic directly without going to base, directly from the collector to base of the transistor T2. When the transistor T2 gets the logic as high logic, then the transistor T2 will become in on state. Then the transistor T2 gives away conducts that voltage from the emitter of the transistor to given to transistor T3, the base of transistor T3. The transistor T3 will also become on. Then the emitter of the transistor T3 gives away the logic, or gives away the output. The emitter of the transistor T3 is given to ground. The output at the Y will be low. This is all similar to the NAND gate truth table. Let us see the truth table of totem pole output TTL NAND gate. I have already said that when both the inputs are low, then transistor T1 will be in on state, T2 and T3 will be in off state, T4 will be in on state, and the output will be high. Same. Next, when both the input logics are what A will be in 0 and B in 1, then second case that same repeats. T1 will be in on state, T2 and T3 will be in off state, T4 will be in on state, and the output get Y is high. Similarly, the third case 1 and 0, A1 and B0, the same repeats. T1 is in on state, T2 and T3 are in off state, and T4 is in on state, and the output is high. But in case of last, both the A and B are in 1, then let us see that T1 transistor is in off state, T2 and T3 is in on state, T4 is in off state, and the output current at I is low. Next topic is CMOS NAND gate. In CMOS NAND gate, the NAND gate is constructed using the MOSFETs. We are using two types of MOSFETs that are N-channel MOSFETs and P-channel MOSFETs. T1 and T2 are using N-channel MOSFETs, and T3 and T4 are using P-channel MOSFETs. The N-channel MOSFETs will be, that means T1 and T2 are in off condition when the input logics are 0, that means low logics. When the input logics are high, that means 1 logics. The P-channel MOSFETs, that means T3 and T4 are in off state. Let us see the working of NAND gate using. When both the inputs are low, means 0, that N-channel MOSFETs T1 and T2 will be in off condition. Whereas the T1 and T2 are connected in series, and T3 and T4 are connected in series, and T1 and T4 are connected in parallel, T2 and T3 are connected in parallel. Although the T1 and T2 will be in off condition, but T3 and T4 are in on condition. Both the MOSFETs T3 and T4 in on condition, then the output at Y will be high. If 1, 0, A0, B1, then the transistor T1 will be in off condition, T2 will be in on condition, T3 will be in off condition, and T4 will be in on condition. The output at Y is also high. Similarly, when the A1 and B0, the transistor T2 and T4 are in off condition, T1 and T3 are in on condition. So the output at the Y will be high. When the input is given as both high, 1 and 1, then transistor T1 and T2 will be in on condition, T3 and T4 will be in off condition. Here we can see the output is connected to T3 and T4, but the input two transistors are in on condition, but the output transistor MOSFETs are in off condition. The output is low, means the output we get is low. This is about the working of CMOS. Let us see the truth table for CMOS NAND gate. We have already discussed when both the inputs are low, then the transistor T1 and T2 will be in off condition, T3 and T4 will be on condition, then the output we get is high. And the A0 and B1, in this case T1 is in off condition, T2 is in on condition, T3 is in off condition, T4 is in on condition, and the output is high. Similarly, in A1, B0, T1 is in on condition, T2 is in off condition, T3 is in on condition, T4 is in off condition, the output we get is high. In this case, A1 and B1, both A and B are 1, the T1 and T2 is in on condition, and T2, T3 and T4 is in off condition, the output we get is low. This is of the truth table of CMOS NAND gate. ECL. Emitter coupled logic is abbreviated as ECL. ECL is the non-saturated of digital bipolar family circuit architecture. It is the fastest among all the logic families, and it is also the basic component of ECL is the current switch. It is also called as CML, current mode logic. In this current switch, the transistor operates in a non-saturated condition at a limited collector current, and this is due to the fact that the emitter coupling used doesn't allow the transistor to saturate it. Hence, it has the fastest switching speed, and the propagation delay is very low of 3 nanoseconds. But the main disadvantage of ECL circuits is the highest power dissipation among all the other logic families. With this episode, we have successfully completed the topic chapter Basics of Digital Electronics. If you like this video, leave a like. If you have any doubts regarding basics of digital electronics, you can comment it down. I will definitely reply to you. And if you do not subscribe till now, please subscribe and please press subscribe and tap the bell icon without for getting faster notifications. Thanks for watching. This is your Nikhilesh Sriram.